Now the condition for symmetry for a two-port network in terms of ABCD parameters. As we have already deduced that a two-port network is said to be symmetrical if Z11 is equals to Z12. So what is Z11? Z11 was V1 by I1 under the condition I2 is equals to 0. If you remember this, you will see what was Z11, how Z11 was deduced. Z11 was V1 by I1 with I2 is equals to 0. And what was Z22? Z22 was V2 by I2 with I1 is equals to 0. So if you remember that, if you go through that, you will remember this, that Z11 is equals to Z22 was the condition for symmetry in case of a two-port network in terms of Z parameters. And now Z11 is equals to V1 by I1 with I2 is equals to 0. That is V1 is equals to AV2 minus BI2, and this is AV2 minus BI2. Then what is I1? I1 is equals to CV2 minus DI2. So it is I1 is equals to CV2 minus DI2. So under the condition I2 equals to 0. So if I put I2 is equals to 0 in this expression, it becomes, these two terms becomes 0. Then it becomes A by V2 by A into V2 by C into V2. So this is A by C. So A by C is equals to Z11. Again for V2 by I2. For V2 by I2 with I1 is equals to 0. So if I put I1 is equals to 0 here, directly from 2 I get V2 by I2 as D by C. So V2 by I2 with I1 equals to 0 is D by C, directly obtained from equation 2. So Z11 equals to Z12 implies A by C is equals to D by C. So C will cancel from both sides, leaving behind A is equals to D. So in terms of ABCD parameters, when A is equals to D, then a two-port network is said to be symmetrical. Right. So I hope that you have understood this, and for the today's first video, you read only up to the condition for reciprocity, and the condition for symmetry in terms of I parameters has been given in video 2, right? So this much for today.